This is section 6.1, part B, multivariable linear systems and row operations. When solving a system of equations, if a matrix cannot be written in reduced row echelon form, then the system either has no solutions or it has infinitely many solutions. When a system has fewer equations than variables, the system either has no solutions or it has infinitely many solutions. So if we take a look at this example, the first thing we need to do is write it into an augmented matrix. When you put this into your calculator and do reduced row echelon form, you're going to end up with 1, 0, negative 1, 0, 1, 2, and 0, 0, 0, 1. So if you take a look at the left side of this augmented matrix, this is not in reduced row echelon form because we have numbers other than just ones and zeros. So when it ends up like this, you are either going to have infinitely many solutions or you're going to have no solutions. If you end up with a row where all of the variables are equal to 0, but it actually does equal a value, so we have 0x plus 0y plus 0z is equal to 1, that's not possible, so there are no solutions. On this one, again, we're going to start by finding our augmented matrix. From here, you'll put in your matrix A, your matrix B into your calculator. Remember, you augment A with B. You're going to store that to matrix C. And then once you have that done, you are going to do the reduced row echelon form. And when you get done, you will have 0, 1, 0, negative 6, and 4. You'll have 0, 1, 2, and negative 3. And you'll have 0, 0, 0, and 0. So if this bottom row ends up with all zeros and that's equal to 0, then this means there are infinitely many solutions. But we actually need to see what those solutions are. So this is x, this is y, and this is z. So we know that 1x minus 6z is equal to 4, and we know that 1y plus 2 is equal to negative 3. Since there is no values for z, we just know z will always equal z. So on the other ones, we want to get the x and the y by itself. So to get the x by itself, we're going to add that 6. So this will give me 6z plus 4. On the y's, we're going to subtract the 2z. So this will be negative 2z minus 3. So these are our solutions. If we write that like an ordered pair, but this will be an ordered triple, we'll have 6z plus 4, negative 2z minus 3, and z is just equal to z. What this means is that for any value z that we plug in, we will get a matrix that works as long as you plug the z in for each part. Now, as we said at the beginning of this section, it's also possible to have less equations than you have variables. If you notice, we have x, y, z, and w. So to be able to solve this system completely, we would need 4 equations because we have 4 variables. Since there's only 3 equations, we will not be able to solve completely. Remember, if there is not a value, there is no W in this case, we do need to put in the 0 as a placeholder. If we put this into our calculator as matrix A augmented with matrix B, you store this to matrix C, then you do reduced row echelon form. You will end up with 1, 0, 0, 14, and negative 25, 0, 1, 0, 2, with negative 3, and 0, 0, 1, negative 2, with 3. Remember, this was your X place, your Y, your Z, and your W. So just like on that previous example, we're going to have X plus 14W is equal to negative 25. We're going to have Y plus 2W is equal to negative 3. And we're going to have Z minus 2W is equal to 3. And because there is nothing for W, we just need to know that W is equal to itself. So what this means is, for any value of W, if we plug it in, then we're going to get something that works. So if we rate this as an order of operations, to get the X by itself, we're going to subtract that 14W. So we'll have negative 14W minus 25. To get the Y by itself, Y is equal to negative 2W minus 3. To get the Z by itself, we're going to add that 2W. So we have a positive 2W plus 3. And then we just have W because W is equal to itself.